Okay, in this section we will be looking at the parabola in an entirely new way, but let's review what you already know. When it is in a y equals format, as I've got written here, the vertex is going to be located at h, k, where you change the sign of the h coming out of the parentheses and leave the sign of the k as it is. This is going to have a maximum value of k and will have an axis of symmetry at x is equal to h, whatever those numbers happen to be. Now we're going to look at this in an entirely different way. We begin with a definition. It is the set of points P in a plane which are equidistant, however you want to pronounce it, from a fixed point, the focus, and a fixed line called the directrix. Okay, now let's spend a little time with this picture I've drawn for you. We have our vertex V at the origin, the way I've drawn it, and we have this focus point which is P units above the vertex, and you have this line called the directrix which is P units below the directrix. So the number P is an important number here. Now, every point on the curve is supposed to be equally distant between the focus and the directrix. So if we take this point here, over here on the right, the distance from the focus to that point and the distance from that point down to the directrix should be equal. No matter where you draw this point or on the curve, it will be equally distant between the focus and the directrix. That is important. Then the line, here's another new definition, which goes runs parallel to the directrix through the focus, is sometimes called the focal chord, but sometimes it also goes by the Latin name, the lattice rectum. Okay, so focal chord or lattice rectum, depending upon the author of your book. Now, the length of the lattice rectum is 4p units long, 2p units to the left and 2p units to the right of the focus point there. Okay, so that's our basic understanding, and you need to understand what P represents. Basically, the distance between the vertex to the focus or the vertex down to the directrix. And if you use the definition here and you set these two distances equal to each other and use the distance formula as I have above here, you come up with this equation here: x squared is equal to 4py. That is when it's centered at, or having a vertex at, the origin. When instead the vertex is at h, k, you have these two general formulas, which you really do want to memorize. The one that has the x squared is the one that opens up or down, so I'm going to draw my sketch this way. And if it begins with y squared, it will be opening left and right, which is not a function because it will fail the vertical line test. And we always need to make sure the focus is inside the curve, and the curve points away from the line, the directrix. I like to think of this as a bean inside of a taco shell sitting on top of a table, just to kind of get the orientation correct. Notice how we have our squared term on the left in both cases equals 4p times the linear term on the right hand side. And we will get plenty of practice with this in a little bit.